quick sound check here. I'm looking at various things to see that my audio is coming through. You might be a little bit quiet. We'll see. I'll see what you all say. Starting in just about 2 minutes, probably now. Good morning! Happy Coding Train Day. It is me, Dan. I was like taken aback by the fact that I had to start. I thought I had another 30 seconds. There's a lot to say, probably as there often is. And I'm, while you are watching the Coding Train, perhaps at this point this should just be called the Nature of Coding Train because I am just still slogging through making the examples in the Nature of Code book, and that's what I'll be continuing today. I do have some ideas for things in the next few weeks, month or two, where I will hopefully take a break from Nature of Code, but I would like to, by June, kind of get through the entire book. We'll see if that happens. But before I do any of that at all, I have to test something. Now I don't know if you noticed something slightly different about me. And no, not the haircut. The haircut I had last week, same haircut. Nope, not this sweater that I don't think I've ever worn before, although I have worn this shirt. It's something else. I will wait for a few minutes to see if anybody can notice something else that's maybe a little different than me. And while I'm waiting, I will take a brief moment to thank the sponsor of today's Coding Train, Dashlane.com. Dashlane is a password manager. If you don't have a password manager, you should have a password manager. And Dashlane is one that you could try. And if you go to dashlane.com/codingtrain, you can get a 30-day free trial of their premium service. And then also, if you choose to purchase the premium service, a 10% discount. And everybody's got it in the chat already. Everyone's saying, yes, new glasses, but not just new frames, which hopefully you, Blue Reflect. Okay, so that's interesting. Let me address that. So the lenses are really what I'm here to discuss because something quite big has changed in my life, which is these are progressives. I've been having a lot of trouble reading, really for the last year or two, and I would have to take my glasses off to read. And so the options, as I understand them, well, besides all sorts of like laser eye surgery options, were to just get a second pair of glasses, so I would switch if I'm going to read. But that's sort of silly because I can just take them off to read, which I was fine doing. The other option was just do nothing. But the third option was get progressives, which I now have. And I have to say, I've only had them I think I got them on Tuesday. So I'm in about 48 hours in, and I'm having quite a difficult time with them, if I'm being perfectly honest, although I'm much more used to them today than I was yesterday or the day before. But I don't know if anybody watching, you're all so young and youthful with your excellent eyesight, So just wait until you get to be me, and you need these. What I didn't really realize is because of the way the lenses progress for distance and reading, there's some distortion on the sides in order to create that progression, and so it's my peripheral vision is less, has a smaller cone, what's the thing? Frustrum. My frustrum of vision is smaller. But the good news is, for you, the viewing audience, because I know your favorite part is me reading random numbers. I'm looking at the chat here. And this I can just do so easily now. The reading is quite phenomenal. I wasn't really able to do it before. So we're going to do a reading of the ceremonial reading of the random numbers with my new progressive lenses. And people had mentioned there's a blue. And so I don't know, maybe this is silly, but I did get the blue light filter in them, which hopefully is not going to be too distracting or cause like weird reflection in me making these videos, but we'll find out. Field of view, thank you. I have a problem. I can't remember words anymore. I think it's related to the fact that I need progressive lenses. It's all going downhill. You may go watch I always say like, oh, those videos are so old, they're out of date. I think I was much more with it then. So let me go back and watch the old Nature of Code videos. 12,931. 52,107. 92,823. 39,994, 74,677, 99,471, 54,065, 54,980, 96,256, 80,823, 25,479, 70,823, 39,006, 79,294, 93,170, 34,469. The music is a bit loud. Okay, thank you. That's useful to know. Oh my goodness, it certainly is. Sorry about that. No wonder everything seemed off. Sorry about that. I'm fixing. Why is blue filter useless? No, I think it is useful. Sometimes I wonder like, what's the real science behind blue light filtering? And what studies have been done and how effective is it? How bad is blue light? How effective is the filtering? But, one thing that I try to do is, I really give myself I should give myself like an 8 p.m. limit, but 9 p.m. after 9 p.m. I try to look at no phone, no screens, nothing. Besides I'm watching a movie or whatever. But, and I don't want the fact that I have the blue light filter to give me an excuse to be like, oh, now it's 10 o'clock at night. I can play Pokemon Go on my phone. Not that that's what I play. I don't play that. No, that's like so 2 years ago, and people in their 40s don't play that anyway. So why would I be playing that? No, definitely not. I'm not like trying to get to level 40 or anything, and I don't have like extra. No. That's somebody else. It's 8 p.m. here, coincidentally. Yes, Shriyang, turn this off. You've got to get to sleep soon. The blue light emanating, it's not worth it. The coding train is not worth it. We'll be here tomorrow morning when you wake up and are fresh. I do use night shift. Yes, I do. I do use night shift. Luke is asking if I use night shift. I also use that, which I quite enjoy. All right. I would like to get into it pretty quickly. There's a little less of the hijinks these days on the coding train. Because I'm trying to be a serious teacher of content. I'll be here till around noon, and that's that. Let's see what other kind of my screen is like distorted, especially if I look from left to right. It's like a waving, bubbly thing. Woo! Okay, but I'm gonna be fine. All right, let's open up the Chrome browser. And let me just mention one thing. And I'm really not mentioning this to ask anyone to buy anything or spend any money. I just want to let you know what's going on because some people have asked. The Coding Train hoodies have hit the minimum number of orders to get made, so they will be on the way. Nobody needs to buy any more. But I just wanted to mention that if you were interested, I think maybe tomorrow I'm going to say, hey, go ahead, that's enough orders. Send them to the hoodie maker. And so I don't know that you'll be able to order them anymore after tomorrow. So if you were interested in getting a Coding Train hoodie, I mean, hopefully we can put them up for sale again or make t-shirts or something new next time. But these are being done in limited runs in terms of how they're being made and the quality. So if you were interested in one of those, might be your last chance. Okay. Also, by the way, I put one of these mugs in the dishwasher here at work, and it got a little faded. So if you have one of the mugs, maybe hand wash it. Hand wash it. Does anybody have one of these? I don't have one of these. If you have one of these, could you send me a picture of it or something? Send it to me on Twitter, social media, whatever. Discord. Join the Discord. That's the other thing that I always like to mention. The Discord has been, as far as I'm concerned, a big success. I don't know if success is the right word, but has been really productive in that it's, I don't know where to tell people to go to get help, specifically related to the content of my videos. There's lots of places on the internet to get code help. Some are, they all have their pros and cons and their sort of vibes and different strokes for different folks. The processing forum, Discourse, it's confusing because not Discord, but discourse.processing.org is a really excellent place to ask questions about processing in P5.js specifically. And I would say there's a lot of crossover between the Coding Train community and the processing discourse. But if you want to engage with getting help from the, laser-focused Coding Train passengers, then the Discord is the place for you to do that. And if somebody, I know that I saw Kobe's name pop up in the chat, can post a link to joining the Discord in the YouTube chat, that would be helpful. Now, I also wanted to mention a couple other things. Google Summer of Code. I think this will get me to the site. I can't remember if I mentioned this or not, but the organizations have been announced. Yeah, because this was announced before. I probably mentioned this last week. But Google Summer of Code is a program that I participate in as part of the Processing Foundation, but there are over 200, I think. Whoa! Oh, no. 686 over however many years. But there are a large number of other open source organizations that participate as mentoring organizations for Google Summer of Code. And you, if you're a student, I mean, you do have to be a student, unfortunately, or fortunately, you can apply to work collaborate with, make an open source contribution to one of those projects over the summer and get paid a stipend. So again, I'm not an official representative of Google or Google Summer of Code. All of the administration and application process and eligibility is handled through them. I'm just here because it's a program that I participate in as a mentor and would love to encourage you to apply if it's something that interests you. And to the extent that I can help with that, or maybe we can open a Discord channel for people who want questions about that, that's something that I would be open to. Thank you, Kobe, for posting the Discord invite. I should probably just get a button. Like I have one button on my Stream Deck. When I press it, it posts choo-choo into the chat. I should maybe make one. I need to get the Stream Deck with with more buttons. I need more buttons. Oh my God! I just want like a giant panel of buttons. That's my dream. All right, so that's that. Nature of Code is what I'm going to be doing. But what are other things? I should make a list of these. It would be so helpful if I just made a list of things that I wanted to mention as opposed to just try to remember them while I'm live streaming. Just think about this for a moment. Yeah. Ah, I thought of it. All right. So there's two things up and coming on this channel that are unrelated to the nature of code. Well, everything's kind of related to the nature of code. One is March 14th is Pi Day, and traditionally I've tried to do something special to mark the occasion. I will be not available to live stream on Pi Day, so I'm probably going to prepare something in advance to be released on Pi Day, but I don't have an idea of what to do. So certainly I'll take suggestions in the Discord. But right now, for better or worse, the system is a GitHub repo where you can, if you have a suggestion for a topic, no, whoa, hold the presses. We have a new member, Jose Garcia del Castillo. Welcome. For your membership with the Coding Train, you have won a random number. And that number is 94,544. You are the sole owner. I mean, I don't think we're ever going to get to 1 million members. That would be kind of nuts. I will just ride off into the sunset if that happens. Thank you. By the way, if you don't know, let me see if I can find, how am I going to do this? I'm looking for, there we go, perfect. This is what I'm looking for. If you're not aware, and I'm sorry if you don't want me to be plugging this, it's too late for you. You put this on the internet, I get to plug it without your permission. Jose teaches a course called Introduction to Computational Design, and it seems like it's at Harvard. And all of the lectures are all online in this playlist. Is this a learning playlist? Or is it just a regular playlist? You should get access to the learning playlist if it's not. It looks like a learning playlist. So check this out. Welcome. Thank you. Oh, I was talking about something. Pi Day. So back to this. So if I go to label, you won't be able to add your own label, but I encourage you to file your issue with your suggestion, and then I will or somebody else will add it. But I'm just going to see what's there right now. So Pi Day 2020, let's see, there's every year, see, look at this. Every year Dan does a couple cool, yes, thank you, I am, as my kids tell me, very cool. I'm the cool dad, definitely. Every year Dan does a couple cool coding challenges related to calculating, visualizing, or using Pi. This year would be a good time to start a Python series. No! No. You can remake last year's Pi Day challenges in Python and also explain Python syntax. It is a really nice idea. D. I'm not sure that that's going to fit with my schedule and figuring out. But I do. There's something there. Actually at my son's school, not to keep talking about my kids today, but they're always on my mind, they have a Pi digit memorization contest. So one thing I was thinking, is there a tool I could build that helps people memorize the digits of Pi? If you have any ideas about that. But really anything that is especially if it's like a beautiful geometric pattern, algorithmic pattern, that's what I really like to do for these kind of challenges, that relate to Pi, and the mathematics associated with Pi, then please suggest that here as a GitHub issue, or talk about it in the Discord. Otherwise, I will be just baking a pie. Oh, that's what I should do, clearly. I mean, because have you all seen the Bon Appetit YouTube channel? I know I'm like really late on this, but it is just chef's kiss. I just wish that I could be like one of their cooking people, which I definitely cannot be. There's no way, but I aspire. I can aspire. I can dream. DT6, oh, which I assume is the same DT, has memorized 80 digits of pi. I would like, how did you do that? Maybe I should just try to memorize them. But the thing is, I don't think I can do a live stream, so I don't think there'll be like a live Pi Day live stream this year, but I do want to do just like a video. Maybe I'll do it as a Cabana one or something like that. Will I be here on Tau Day? Yeah, maybe I'll just wait till Tau Day. So that's number one. Number two is, insanely, and I really don't understand how this is possible, but it seems as if this channel will soon have 1 million subscribers. And I'm assuming that then the next day they'll just like everybody will unsubscribe, but you know, probably at least for a day. And I mean, I kind of want to do nothing, like just like keep going as I'm usually doing, but people are asking, and maybe it is a nice thing to think of doing something special to celebrate that. So I could use ideas. I really want to do something with the original, I know I'm gonna keep mentioning this till somebody, if you live near like a rare bookstore or have some way of finding a copy of an original print, I will pay for shipping, I will purchase, all of these things. I would very much like to purchase a original print of this million random number book. I have found some listed online, but there's no way for me to authenticate them. And I've emailed and asked, and mostly I'm seeing them through Amazon listings, and no one will give me any real information, and I don't feel like it's a good idea to spend a large amount of money to purchase something that I have no idea what it really is. Okay! Welcome! We have a new member! All aboard the Coding Train! Adrian Hitch! With your membership of the Coding Train, you have won stickers in the mail. Eventually, sometime in the next year. It takes a while. We're slow. I'm slow. Also, your very own random number. 11,827. New member that I already now can't see in the chat anymore. I think it was Adrian. That is your random number. You are the sole owner of the random number 11,827. Please write that down because I won't remember. I suppose a lot of the numbers appear more than once in this book, though. So you might have an issue there. This is the million random digits. Doesn't mean the million unique random digits. Okay. Now, so that was that. Ideas for any kind of special video for 1 million subscribers. The other thing that's on my mind related to that, what was it? Oh, yes. I'll bring this up in the Discord. And maybe I am working on training a machine learning model to generate text based on all of the captions of all of my videos ever. And I could use some help with that. So, but that I'll bring up in the Discord, or that's a separate thing. All right. Number file showed that 39 digits of pi would calculate the circumference of the known universe to the width of a hydrogen atom. Whoa. Whoa. Okay. That's intense. Oh my goodness. Simon says that is calculating the rate that I'm getting subscribers and estimating that this might actually happen on Pi Day. Well, can you slow down, please? I'm not ready. April 1st, I think, is a much more appropriate day for me than Pi Day. I said that last week. Okay. So I think I better get started. It's 10 o'clock. Half an hour should really be my limit of shenanigans. Let me go to the web editor of P5. Oh, wait. Hey, what's going on here? Oh, there we go. Look at this. Huh, isn't Dashlane wonderful? It got me logged into the Coding Train editor. And I have no idea what my password is, and it doesn't matter because I'm using Dashlane. Okay. 36, I think, is the number I tend to use. Let me go to where I left off last. Whoa, what is going on here? Oh, by the way, this is kind of an aside, and maybe I shouldn't be showing this, but let's see if this works. I was helping a colleague who's teaching a class about animation, and this is like an animation I think made, is it made in Illustrator? No, in After Effects, but using a library called Lottie.js, and these are some like Lottie and P5 examples. I actually don't know what I'm talking about, but I helped him make this. But it's cool because like the whole animation is all just in this big like JSON file, and then I have P5 like playing it back, which is kind of cool. All right, but that's someday I would like to make some videos about this with Alon, who I worked on this example with. Okay, coming back to opening my sketches, the one that I want to get is this. Here we go. So this is where I left off. This is the last, this is where I left off. Amar writes, we miss Atom or VS Code. We don't like the browser-based editor. Too bad. That's what I mean. No, I get it. And thank you for your feedback and your comment. It's important for me to use this editor because it is a tool that I feel very invested in helping it grow and for it being something that is a really friendly, easy place for people to start to learn coding. So when I do certain projects that really don't fit well with the web editor, I certainly will do things outside of it, but I do feel like it is a useful tool for me to demonstrate the basic nature of code examples. Okay. Hello, Argentina. People of Argentina. Okay. All right. I'm just trying to figure out where I want to kind of begin with this. All right. I am going to actually go whoops, no, I don't want to download this. I'm going to go further back. Friction forces 1. I think this is, yeah, this is where this is the example I'm going to build on. Okay. I really am having trouble because I don't have peripheral vision, so to see the screen over here, I have to turn all the way to the side. Okay. I'm going to need to start all my recording things, so let me do that actually now. Start recording. Let me go here and set the multi-quarter to go. One thing I also want to mention is I've had a little bit of audio interference, I've noticed. It must not be significant because nobody ever says anything during the live stream, or at least I don't catch it if you are. If you're noticing like a little, almost like, just like sort of like a high-pitched hum that sort of like slowly fades in and fades out. If you're hearing that, could you let me know at any point? And I'm just trying to get the various chat things back up. Here is, there we go. Okay. And then I need the YouTube chat back up. You can see that. Oh, Simon is giving me some excellent suggestions about additional things I could do. You know, I've got to move on to chapter 3, but I hear you. Read the entire book online for free. How nice. Okay. And then I want to go to, where am I? Forces. I'm only in chapter 2. Boy, this is going very slowly. And where am I? Here we go. Okay, so this is what I'm going to be doing today. I am going to go through this particular scenario and example. I need a minute to pull myself together here. And by the way, I don't want to show this diagram because this diagram is absolutely incorrect. There's a major flaw in this diagram. I can't remember if I fixed it or not, and it's just not on the website. But this R needs to be the distance between the centers of the bodies, not the edges of the bodies. So I hate to show this. I mean, one option is we could replace it later. So maybe Mathieu, what we're going to do today is I'm going to leave this flawed diagram up, and then I will fix it in Illustrator, and we'll just like replace that in post. Even if the recording system isn't working and we don't have the separate green stuff, we can. I'm pretty sure like overlaying a diagram should be possible. Although I'm going to like point to it and stuff like that, so that's going to really mess us up. But whatever. We're going to try our best. We're going to hope for the best, everybody. But that is an absolute mistake. All right. So if I'm making a brief list, I'm going to. Is this overhead thing working? No. What happened to my overhead camera? It's so sad. That's weird. Oh well. I am going to, let me make a list. So the first thing I'm going to do is just do attraction. And then I'm going to, I think in the same video I can make an array. Making notes to myself here. You know what? Usually I type these out. Let me do that. So you can see it. Right, because actually I have it here. Right. Okay, here we go. Oh, right. So I've done all these. I already have these notes. All right. So this is done. So gravitational attraction plus array. I think I could do that in one. We'll find. I might change that, but I think that can be in one. Then I'm going to do repulsion plus like a kind of group behavior. So instead of there being separate attractors, a separate attractor and movers or bodies, whatever I want to call them, particles, I'm going to have them interact with each other, and then I'll add. And I think this could all be in one. So I think hopefully this will be two videos where I implement the basic gravitational attraction. Then I just switch it to repulsion and show how you can make it a group behavior and a wall force. And then I also have, I should look, like some of this is a little bit redundant content because last year I did a traction coding challenge. Coding challenge 56. I guess that's more than, no, that's, whoa, 3 years ago? Are you insane? Have I really been doing this for this long? That it felt like, oh, that was just last year. That was 3 years ago that I did the attraction and repulsion coding challenge. Let's just look at the code. I'm hoping that I was using ES6 classes at the time. Or I changed it. Whoa. All right. Okay. So then there's also this. So I'm going to refer to this coding challenge and also include it in the playlist. And Arnav in the chat and my minds are exactly aligned here. Arnav, don't forget to mention your coding challenge on attraction and repulsion. Okay. So yeah, so a few years ago, I didn't feel like I had time to redo the full Nature of Code tutorial series, and so I just picked and choose little things and did them as coding challenges, which in many ways makes more sense because I kind of make one video that has a whole lot of concepts all in it. But this year, I'm doing it differently, and as soon as I do this, I can no longer see because this is the reading part. Distance. Reading, distance, whoa, I'm dizzy, coffee. Okay, so that's there. This is Jose's playlist. And I mentioned Pi Day. Anybody file any issues? Come on, I need some Pi Day ideas. Okay, and then here I am. And then here I am. All let me just... Actually, you know what? I'm going to do this. Get rid of this edges thing. Oh, boy, boy, boy. Duplicate, duplicate, duplicate! Oh, did I mess it up? Hold on, everybody. Let me just, I might have messed up that other example, and if I did, I just want to check real quick. I think I did. Oh no, I left it. I might have like changed something, but oh yeah, okay, so this doesn't need to be in there. And mover is fine. Okay, great, that's fine. Now I'm here. Get rid of the edges function. And oh, I also want mass. Hold on. I don't need edges. I don't need this. And let's see. But I also want to get the idea of mass back in here, which I implemented in the previous one. This stuff would be nice if I did this in advance, so apologies. A drag. So what I did in the previous one is added mass. Oh, wait, hold on. And then I calculated the radius based on the mass. So that's going to go in here. And it's going to take a third argument. And then also divide by mass. And then add that. And then what else? What else? What else? I think then I just need to give it a mass here, like 5. Okay, great. All right. I love the Wesley Crusher reference in the chat right now, by the way. All right, Adrian, thank you for your new membership. Coincidentally, I happened to see your message in the YouTube chat, but Pi Day suggestions, if you want me to see them, the Discord or the GitHub repo is the best place. All right. But please, talk amongst yourself about all sorts of Pi Day ideas in the chat. I don't need this anymore. All right, here we go. Is there, oh, look, are you serious? Oh, this is the worst. Okay, the worst, this is the terrible thing that I have discovered on the internet today. That when, I mean, this might, no, I'm not signed in. When you search gravitational attraction, this image comes up, which is from my book, which you would think would be great, but it has a mistake in it. Oh, look at this. What a coincidence. So by the way, the book is Creative Commons non-commercial, and Khan Academy, when they unfortunately used the incorrect diagram also, has basically a duplicated version with a bunch of changes of the Nature of Code book. Hopefully that I'm credited on here, but I think that I am. But I'm looking for, yeah, this is what I want to look for. Yeah, here we go. All right. I have such trouble getting started, but it is time for me to get started. Got to get some stuff done today. Not looking at my email. If I wanted to, I could just pick up my phone. I have progressive lenses, so I can see it really well, and I could see if I have any important messages. But what could be more important than what I'm doing right now? Nothing. But the phone is going further away. I see it out of the corner of my eye. It's going over here. I'm taking this Coding Train notebook. I'm taking the phone. I'm putting the notebook on top of the phone. And it's going over there. All right. I'm going to start. I'm having trouble. Where's some encouragement, please? Although by the time I'm going to have started by the time you hear me say that, so never mind. Okay. Stretch. Everybody stretch. If you're watching and you can, whatever works best for you to like move any parts of your body that you can move, stretch. Oh, so Raul says just heard the noise, hearing the chirp. What can I do about that? All right, I have a suspicion that maybe where this receiver is placed. So hold on, I have an idea. So thank you for telling me that you heard the chirp. And now I'm hoping I moved some wires around. Hold on, there's one other wire that I should maybe move that could be having like some interference. Okay, so hopefully that's going to do the trick. You need the CJ timer, I definitely do. Okay. Happens when I do certain poses. Oh. Could it be, I don't have any, I don't have any other electronic devices in my pocket. Could it be the zipper or something? This is the mic. Well, all right, everybody listen. Listen. Standing still, talking. Does it happen? I'll do anything to not have to do the coding tutorial. Can you tell? Okay. Oh, it's 10. All right. This is gotta start. All right. Hello and welcome to another. Every video starts with me saying that. I mean, nobody wants to look if they're watching the sequence and I just keep saying hello and welcome to. But I don't know what else to say. All right. No, I don't like starting with that way either. It is time for Newton's law of universal gravitation. So this is the final example that I will be demonstrating as part of Chapter 2, although the concept of forces and how they are applied permeate throughout the rest of the videos that I intend to make. But I'm going to wrap up this chapter by looking at the equation for universal gravitation that looks exactly like this and trying to see, can I take this equation and implement it in a P5JS sketch? Okay, so that's good. That's definitely what I wanted to say at the beginning. So much, yeah, this is with our, we're going to sort of hope we can fix this. We'll see. Well, I can always come back and re-record or something. Okay. And let me just see here. here's the same formula with a diagram in the Nature of Code book itself. So the idea of this law is that every body, every particle, everything in the universe attracts every other thing with a force that's proportional to the masses of those bodies and inversely proportional to how far apart they are. So the farther apart they are, the weaker the force. The closer they are, the stronger the force. I did something very much like this in the first example as part of this series where I had, actually, look, let me actually put this here. All right. Oh, it's my watch. Is my watch doing it? Okay, that's easy. I don't need to wear this. Silly, overpriced piece of hunka. Exercise, tracking, surveillance, couture. Okay. Woo! I feel so free! My phone and watch are gone! All right. So I don't think it's worth me. Was it really bad? And is it really bad that I need to go back and redo the intro, or was it fine? Like the glitchiness audio, it's going to end up in the edited version of this, but if it's just like a little minor hum, big deal. Did it happen again? All right, I'm going to just keep going. Heard it again. Oh, well. What could it be? I wonder, I guess I could change the, is it just the bell? Fine, good. All right. All right, I'm gonna keep going. In the first example in this chapter, I did something very similar to this idea of the law of attraction. I created a vector that points from the mover object to the mouse, and then made that vector the acceleration of the mover object itself, and it appears as if it's this body like orbiting the mouse itself. I got it. There is sort of a problem with me keeping my eye on the chat. It's very distracting and I lose my momentum. So I'm going to just take a break from looking at the chat, and I'm going to plow forward this because I shouldn't keep stopping and starting. Oops. Hey, what's going on here? I did something in the first example in this series very similar, where I took a mover object and created a vector that pointed from that mover object to the mouse itself and set that vector as the acceleration of the object. So this was like attraction, but I wasn't thinking about mass and I wasn't thinking about distance. Let me try to diagram what it is that I want to do. I want to have a new object that's called an attractor. So I'm not actually going to, at this moment, I realized something. Let me diagram what I want to do in this video. So I'm going to simplify things and have this concept of an attractor object. So the attractor object isn't a real body in the universe. It's a fixed entity that attracts things to it. But it cannot move and it cannot experience forces itself. Then I'm going to have the mover object with some given velocity. And the mover object, the attractor is basically the mouse from the previously, but the mover object is going to experience a force, a gravitational force, that pulls it to the attractor. And that force, which is a vector, is going to be equal to the mass of one object times the mass of the other object divided by the distance squared. And I put this in the wrong order, but also times g, which is the universal gravitational constant. Now there's a very real number that is this value in the universe as we know it. But for us, in our fake P5, or I don't want to say fake, I'll say pretend. But for us in our pretend P5 canvas, oh, well, that's where. Okay, I understand what I'm doing now. But for us, in our pretend P5 canvas, if I draw like a box around this, the G is just a way for us to kind of like tune the world to have stronger gravitational attraction or weaker attraction forces. And in a way, I could think of this G as a property of the attractor itself. Maybe different attractors have different constants, although to some extent that is taken care of by the mass. But I have everything that I want. I can make up Stop stopping and starting, Shiftman. So I need everything that's in this formula. I need to figure out where is it here. So the mass of one object, well, would be the mass of this mover object. The mass of the other object would be the mass of the attractor. So to some extent, the mass and g, I could conflate these into one constant, but I'll keep them separate for now. Distance is the distance between the centers of both objects. So remember, when I'm calculating a force, I need two things. I need direction and I need magnitude. So this is really, all of these numbers are talking about the magnitude. How strong is that force? How long is this arrow that I'm drawing here? The direction is just a vector that points from the object being attracted to the attractor. And so that I can get, if you remember, I've done this a bunch of times now, with subtraction. So the sub function for subtraction, I can take the position of the attractor minus the position of the mover, and that gives me a vector that points this way, set its magnitude to the result of this formula, and voila, I have gravitational attraction. Okay. So coming back to this example, I am going to now get rid of this acceleration calculation. And when I run the sketch, I should just see this mover not moving at all. And in the main JavaScript file where I have set up in draw, I want to add an attractor. So I'll create an attractor that also gets an XY position and a mass. I'll say attractor.attract mover and attractor.show. Now, I might have just confused you for a second there, because you might be thinking, wait, did I miss something? Did you write an attractor class? And is this just going to work right now? Definitely not. Like when I run this, it's going to be like, I have no idea what that is. So this is the way that I work sometimes. And there's a little bit of flaw in me making this tutorial video because this is probably an example that I've written many, many times. So I had it just sort of right in my mind at the ready. But sometimes it can be helpful to sort of sketch out how it is you imagine writing the code to operate an object before writing the class. Because now I have the instructions for what it is I need to write. I need to make a class called attractor. The constructor takes 3 arguments. It needs to have a show function, and it also needs to have an attract function that receives a mover object. So all of these things are now things that I can write into the attractor class. I've already created another JavaScript file, attractor.js, which is empty. So I'll put class attractor in there, then write the constructor. Which, if you remember, required 3 arguments, an x, y, and a mass. The x, y I'll use for position. The m I'll use for mass. Let me write a show function just to draw it as a circle. I'm now realizing I should calculate a radius based on mass the same way that I did in the previous examples with the mover. So I'm just going to grab this code which takes the mass, takes the square root and multiplies by 10. I'll use the same convention. And then, so let's leave out the attract function for a moment. Comment that out. Move the mover to like a little higher up in the canvas. Run it, and what do I have now? Ah, attractor is not defined. Oh! I can never seem to remember to add the script tag when I have a new JavaScript file. And here we go. All right. Now I see the attractor and the mover. So the I look at the chat. Now I see the attractor. Sorry. I gotta stop looking at the chat. Now I'm seeing both the mover object and the attractor object. The next step is just to actually write a function in the attractor object that, did you hear that loud noise? You have a vector on the left side. Feedback was bad when you were at the white. Hold on, time out for a second. The feedback was bad when you were at the whiteboard. Might be from the mic cable moving. So what mic cable moving? You mean just like this? And then you have a vector on the left side and a scalar on the right side. Oh, yes. Yes. Okay, people are telling me that the noise is annoying. I don't think it's an OBS problem because I think it's also in the audio track of I have another system that records a backup of everything. Zipper gets close to the mic. I mean, that doesn't really make sense, right? I mean, that's going to make it have noise, but I mean, I've done streams without zippers before. Oh, you don't see me right now. Bum, 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 bum. What do I do about this? I don't think it's mostly when my hand is near the mic. My ring? This hand? So I'm taking a pause for a second to figure out if I can sort this out at all. I'm trying to think. Charger? What charger, though? Okay. Yeah, it's interference. It's a okay. Well, yeah, it's fine. I guess just let me know if it was particularly bad. The gain being too high. Yeah, I have that down. I don't think it's feedback though, but one thing I can do is just turn off. Let me just check one thing for a second, okay? It was really bad just now. Huh. Yeah, people are saying my phone, but my phone is so far away. I'm just wondering if I turn the audio monitoring off. What's weird? It's interesting because I'm not hearing it. Oh wait, I think I just heard it. Yeah, I hear it. Oh yeah, I hear it. Okay. Playing with the receiver. Oh yeah. Okay, that is really weird. I was able to get it to, was that just a coincidence? Yes, you were watching a person and move around, trying to figure out if there's a way to trigger the audio interference. All right, I have an idea. I have another lav mic. Let me just try the other lav mic, which I should have done a million years ago. So I'm muting myself for a minute. Okay, test 1, 2, 3. All right, I think this mic is working and it doesn't look like it's crazy loud. So the question is there interference? Is this better, worse, the same? Test 1, 2. Huh, I don't hear it. Too loud, okay. Well, that's easy to fix. Okay, that should have turned it down a tiny bit. And hopefully the interference will be gone. We'll find out. Okay, so if you hear any audio issues, let me know. But I'm going to assume that hopefully fixed it. Wow, it's 10:40 already. I'm going to be taking a break shortly. Great. I actually have a third idea of something I could do if it's really bad, because I have new wireless headphones, and I wear them, and the mic quality is actually pretty good. So, but anyway, well, everyone's saying the mic is better. They're exactly the same mics, it's just two of them. All right. Okay, that was a burp. Did you click that up clearly? Sometimes it's easy to forget you're live streaming, and the body just does what the body wants to do. What's become of me? Oh. All right, I'm going to move on. Okay, so. Okay. All right. Now you're catching up to me in real time. I'm going to move on. You know, while I took this break, just give me a second to check. I'm just curious now to see how the recording is going. Okay, all right. Now, if I could only remember where I left off, but here we go. Now I can see both the mover, which isn't moving at all, which is what it should be doing, and the attractor just as a circle. There's a better pick suggestion in the share channel. Could you repost it here? Because it's not easy for me to check other channels. Someone repost it in the live chat supporter group. The problem is it's going to be a while till you hear me say that. Okay. Can I please move on? How's everybody doing today? Okay? Everybody feeling okay as things in the world are spiraling? Everybody take a deep breath, relax, hug your neighbor, friend. All right, I'm going to move on. I'm waiting for it to appear, but I don't think it's going to. Oh, there it is. Oh, thank you. Perfect. Yes, that's exactly what I intend to do. Yes. That's a great diagram. Whoever made that, thank you. How do I pull that up here? Hold on a sec. Hey, can someone make my... All right, I'm moving on. Thank you for that diagram, but I need a better system for all sorts of things. I got to move on. Okay. The account that there's an account that I log into Discord on this laptop that's not in the supporter channel. Oh, I could have checked share. DurCarol687. Okay. All right. Everybody, I'm moving on. Okay. Now I have the mover, not yet moving because no force has been activated, and the attractor just in the canvas. So the next step is for me to write this attract function and implement the formula. But before I do so, let me address something. Why did I choose to say attractor.attract mover? I could have said a number of other things. I could have said I could have called, I can't get the momentum back. I could have called a function. It's gonna be okay, everybody. Here we go. I could have called a function on mover instead of attractor, or I could have written a new function that takes the two arguments, the mover and attractor, or I could just work out the code in here. So I'm making a somewhat arbitrary choice, but to me it feels conceptually consistent to have the attractor object itself have the functionality to create a force that attracts a mover object. But if you want to try to redo it and reorganize your code in another way, I would really encourage you to do that and share it with me. Returning to the diagram for a second, I did make a sort of slight mistake here, which I am calculating a force, and I talked about wanting to calculate a direction and a magnitude, but this whole... Why? Whoa, what just happened? All right, everyone, don't worry. I have a solution for this. Apply force to get momentum, yeah. Now I did make a sort of small error here, or inconsistency, whereas that I'm saying I'm calculating a vector, but all of the variables and aspects of the formula that I'm working with here are just calculating a scalar value, the magnitude of that vector. So let me be a little bit more clear about this diagram. If I have two objects, each with a mass, and I'm calling this vector, or this, what am I saying? If I have these two bodies, each with a mass, this one being the attractor, but that doesn't really matter so much, and I think of this vector pointing from object 1 to object 2 as a vector r, then the distance is really the magnitude of that vector squared, And then the direction is the unit vector r, which I don't really have a lot of room here, but I could say, let me, oh, no. Which I could write as r with the hat on it. So now this formula is more accurate, and all I need to do is calculate both, in my code, is calculate both this unit vector and this equation, put them together, and apply that force. And I'm going to do all of this in a new function called attract. That's part of the attractor. So let me first get this vector r. I'll call it direction. And it is the mover, sorry. It is this position minus the mover's position. And I need to say subtract. The distance is the magnitude of that vector. And actually, I'm going to want distance squared. So let's make this distance squared as magnitude squared. Oops. I'm going to make up, just for right now, a universal gravitational constant of 1. So I could really just ignore it, but let's keep the variable in there and just set it equal to 1. And I'm going to use the word strength to calculate the magnitude of that force, which is this dot mass times mover dot mass I'm going to give myself more room here, divided by distance squared and also g times that. So this right here is exactly the same formula that I have right over here. And I just want to take this vector r and set its magnitude to the result of this. So, just to be consistent, I'm actually going to rename this from direction to force, because ultimately I'm going to use this variable. I'm going to use this variable to be the force, and then I'll say force.set magnitude to that strength, and then mover.apply force force. Clean this up for a minute. And we can see I have all the steps here. Get a vector that points from the mover to the position, the mover to the attractor. Get a vector that points from the mover to the attractor. Calculate all of the elements to get the magnitude of that vector, put it in this variable strength, and then set the magnitude of that vector to strength and apply the force. I don't know, let's run this. Is it going to work? I think so. I'm not seeing anything. Okay, well, one thing would be to actually call the function attract. Strength is not defined. All right, that must be a mistake that you've all noticed. Strength with an R. Oh, wait, it is moving. Just ever so slightly and slowly. This is where having G can really come in handy. let's make G 5. And let's make G 50. There we go. So I can scale the force relative to that universal gravitational constant. But there's actually something else going on here that I think that I would like to fudge. While I really would love to stay so true to this formula, you are a wonderful formula, and I want to stay true to that formula. Give me a little bit of wiggle room here, because this is this made-up P5 world. It's pixels, and there's a lot of aspects to what the feeling that I want to create and how it's actually going to behave with this literal formula. And one of the, like a big element here that's playing a role here is this distance squared. As you think about it, the amount of pixels apart that these could be could very easily be, 200 pixels. And if they're 200 pixels apart, that's going to be, dividing by 40,000, which is going to make the strength of the force very, very, very small. So I could increase the mass of everything. I could increase G. But ultimately, something that I might just do is kind of constrain the distance that I'm using in the calculation to a limit. So I'm always going to, even if it's farther than 50 pixels away maybe, just cap that at 50. On the other hand, when they're really, really close, they could actually be in the same spot, in which case the distance would be 0, which doesn't make any sense in actual reality, but could happen here. Or even if their distance is something like 0.001 pixels apart, if I were to square this, to have distance squared and then divide by it, I'm going to make that strength so strong that things could kind of spiral out of control. So this is something that you could really play with and sort of like try a lot of different scenarios. But for me right now, I'm going to say that whatever that distance is, I want to constrain its range when I go and calculate the force's magnitude. To do that, I'm just going to use the P5 constrain function. And now I am getting the magnitude squared, which I don't love. So I'm going to constrain it between 25, which is 5 squared, and 50 squared. Which is 2,500. 2,500 people! And 50 squared, which is 2,500. Let's see what happens now. I'm just like sitting here. All right, this is like this range that you want to play with is something, there's no science to what I'm doing here, specifically because I'm like violating the actual rules of science. But this is something that these are parameters that you may want to play with based on what it is you really want your system to do. In this case, what I want to see is it actually having. In this case, I think this would be a better demonstration if I give that mover an initial velocity. So I am going to do that. I'll give it a random one, just so we can see different things. And it has a bit more of the quality now of a body orbiting this attractor. It's moving so slow. Did I have a limit in here? No. One thing that might actually make sense here is to get rid of this multiplier of mass and actually just give the objects bigger mass. So I'm going to give the objects a mass of 50 each. Whoa. Yikes. Well, I guess let's give them and then let me just multiply it by 2. Oops. Where did I mess up? Oh. All right, this is what I was kind of looking to see. And actually, it would be interesting to trace this. One thing visually that I think might be interesting to do is trace the pattern. Over that, I can give the background quite a bit of alpha. And we can kind of see the path that it's going in. And then even better, let me make this an array. So now I'm making, and I got to add this in here. Now I'm making 10 mover objects. Oh, and I want to give them each at a random location with a random mass. So I'm going to just put 10 out into the canvas. I'll make the attractor a little bit bigger with mass. And then I have to loop through them all in draw. Let me give a bit more pixel space to work with here. And let's see what this looks like. Whoa, what happened to the mover? Oh, no, it's, OK. Let me put the mover in the middle. And I think I want to draw the mover a different color to make it more obvious. And I'm going to make this constraint of the distance even smaller. So it's still weighted according to distance, but it won't be as extreme. And let's see what this takes a look like. So now, again, what have I made here? I don't really know. But what I'm showing you, and actually, I want the initial velocities to be a bit stronger, I think. Will also make this demonstration a little bit nicer. There we go. So this is what I was more hoping to see. So what I'm looking to do here is create a bunch of mover objects that are sort of orbiting and swirling around this one attractor. And you could imagine, oh, what's something interesting that I could do here is that I could actually just right now, in just a very quick moment, I could say, hey, you know what, the attractor's position, if mouse is pressed, if the mouse is pressed, move the attractor to where the mouse is. I'm not sure what that really added. But I'm getting somewhere. I'm getting a sort of swirling set of bodies all experiencing gravitational attraction to this one attractor in the center. The upper limit is too low, I think. Yeah, that's all coming next. What Amr and Simon are both asking about, well, shouldn't these objects be attracting each other and also attracting the attractor? That's coming next. I think you might have confused the naming of mover and attractor. Where? What did I say I was going to do next? Repulsion, group behavior, and wall force. Okay. Reduce the trails, yeah. Let me just take out the trails completely. And removing the trails, this is what I have. Oh, I confused attractor and mover in my verbal explanation a few times while setting the color and mouse position. Huh. Oh, I should put the mover in the center. All right, we'll dub this over later. I should put the attractor in the center. I should put the attractor in the center. Is that how I said it? I should put the attractor in the center. And I should put the attractor in the center. Right? Give myself some extra audio. This example might actually look a little familiar to you. About 3 years ago, I did a coding challenge called Attraction and Repulsion, where I essentially built exactly this, but I had multiple attractor objects. And I also took that attraction formula and multiplied it by -1 to reverse the direction to make it a repulsion force. So those are things that I would suggest trying. Like, what would it mean for you to add multiple attractors? Maybe every time I click the mouse, a new attractor is placed in here. How could you adjust this with repulsion? But what I want to do in the next video is make a couple changes to this. One is I want to show you repulsion, so I'll do that. But really, there's a big flaw here in terms of how the universe works. I mean, there's no flaw in. You didn't see that, but I just ran into the wall over there because I'm frustrating myself. So this is what it looks like without the trails. And you can see I've kind of like wrapped up this example that I wanted to make. And there's a lot that you could play with here. Incidentally, this might look very familiar to you. About 3 years ago, I did a coding challenge called Attraction and Repulsion, where I made exactly this. The difference was I took it a bit further, and this is something you might think about trying on your own now with this as a basis for your example, is what if I were to click the mouse and add multiple attractors? What if some of those weren't actually attractors at all, but repellers? How would I make a repulsion force? It's actually pretty easy, just multiply by -1 to reverse the direction. So I'm going to actually do some of that in a follow-up, which will be the next video in your playlist here. But what I want to look at more closely, though, that neither this example or that previous coding challenge addressed, is what if I want every mover object to exert a force on every other mover object? What if, going back to this original diagram, right, where what if, going back to Newton's law of universal attraction, every particle attracts every other particle? So really there should be a force all of these should be attracting every other one. And what does the system look like if I have a lot of bodies floating around all mutually attracting each other? So that's what I'm going to focus on in the next video. It's a bit of an introduction to a group behavior. I might need like a nested loop. We'll see. And that'll really wrap up this chapter 2. Okay. All right. I'm going to take a short break right now. And I will come back and finish this off. I'm glad we have the audio thing worked out. There's a lot of people watching this right now, which is always mind-blowing to me. I need to get some like water or coffee or something. But before I take my short break, let me really thank the sponsor of today's live stream, Dashlane, which you can go to at dashlane.com. So what do I say? Oh, actually, I have a little story to tell. Let me come back. So I was talking back to my son again, who's now programming in Scratch. My daughter's also programming in Scratch, but she's a lot younger, so it was a little bit harder for her. But she's doing a great job. But he has an account that's part of his school, and I was asking him, what's because I wanted to see what he was doing. I was like, maybe I'll just log into your account later. Like, do you know your password? And he was like, yeah, I know my password. I was like, well, how did you get a password? Did you like get assigned to you? Did you make one up? He was like, I just keep my password in a file on my computer, on the computer that he uses for school at school. And I thought to myself, oh my goodness, I am not teaching my children proper password management. And if you're doing things like all of your passwords are on just like a plain text file sitting on your computer, or you have the same password across everything you're using, this is not good. There's lots of things that I like to attempt to do my best to sort of like protect accounts and not use, and so one of the things that I can't live without really is a password manager. And what a password manager does, Dashlane being a great service, password management service, is that it allows you to have different passwords everywhere. Everywhere. Don't hurt yourself, and have them all stored in a single place in a secure fashion. And then, frankly, it just makes life like super convenient when I'm trying to order a very expensive copy of a Million Random Number book original print on eBay, which is what you're seeing me do right now, only I can't because I can't find it. Can I please find it on eBay? Someone help me so I could use my Dashlane to quickly enter in all my information to buy that expensive Random Numbers book. What else do I want to tell you about Dashlane? So there's a few things that are important. So one thing is Dashlane is different than other options that you might have already for automatic logins. Solutions like Keychain and Chrome, they lock you into a single system, so your passwords and info are trapped in one place. Sign-on solutions like login with Facebook can misuse your data because they make money from collecting it, selling it, and using it to annoy you with ads. So Dashlane never has access to your personal data and won't trick you into subscribing. There's no credit card required at sign up. Not even Dashlane can see your data, and it's always an ad-free product. So really, for me, this ability to like fill in forms fast with one-click logins and autofill, you saw me do that with the P5 web editor, is just so incredibly convenient. It's so nice to have something that I can use across a Mac, Windows, a mobile device, whether it's Android or iPhone, and really sort of like respond easily to breaches and hacks with personalized security alerts. So if you're interested in giving Dashlane a try, you can go to dashlane.com/codingtrain. If you sign up through that link, it lets them know you found it from the Coding Train. Thank you very much. And you'll get 30 days of free premium subscription to all of the features. And then if you choose to purchase it, after those 30 days, you'll get a 10% off the premium subscription. So I thank you again. Thank you to Dashlane for being a sponsor. It really helps make all the stuff that I'm doing possible. And I am going to take a break and come back to this coding example. So I think it'll probably be about 5 minutes. I'm just kind of like getting all my various windows back up here. I'll see you. I'm gonna do the next part of this. I wanted to get to chapter 3 today. We'll see if that happens. I've got until about noon. So I'll have, when I come back in 5 minutes, I'll have about 40 minutes left to like plow through some more examples and stuff. Thank you for watching, and I will see you in about 5 minutes. Hi everyone. I need about 1 more minute, so I'm going to set the music back a little bit, and I'll be back soon. Okay, sorry for the delay of train. Whew. All right, I've got some water. Thank you to Dashlane as the Coding Train sponsor, and also water, which keeps me hydrated. All right, what is next? What is next? Just spill a little water on the computer. Everything's going to be fine. Wipe that up. And, whew, okay. So now I can move this here. And this is the last video tutorial I am going to make as part of Chapter 2. And I guess Chapter 3 will probably have to wait until another day. I mean, there might be enough time after I'm done with this next demonstration for me to continue into Chapter 3. But I sort of feel like, I mean, if I'm going to do, it would be so much nicer, I think, in terms of keeping everything together and having a nice flow to the videos, for me to do a session that's dedicated to Chapter 3 as opposed to like starting it at the tail end of one and then coming back a week later. So, you know, if I have a little extra time, I'll answer some questions or talk about something else. But I will be here until noon either way. Okay, now we're talking. You know, I could just sort of dance around and act ridiculous at a minimum for like the last 10 minutes. All right. So I'm going to save this and duplicate it. All right. And ready to go. Okay. I don't know. Why not? Let's keep going with this. I actually really like this example. I am back with one more demonstration, and really, this finished. One more video here in chapter 2. I want to just do a few more things with this example. So the previous example, I built this sketch where there's a single attractor at the center of the canvas, and all these other mover objects are experiencing a gravitational force pulling them towards that attractor. And all of that happens in this function called attract, where I am writing code to realize this particular formula for the universal law of attraction. But this is not really how the universe works, in the sense that there aren't separate attractor entities and separate mover entities. So let me take this a step further and have every one of these mover objects, and I really want to just call them particles, but I'm going to wait until chapter 4 to call things particles. But every one of these mover objects attracts every other mover object. And I'm going to get rid of the attractor. No more attractor concept whatsoever. Before I get rid of the attractor, but before I do that, let me save this code, because I'm going to want to use this code. So I'm going to take this code and put it actually just in the mover object itself. Then I'm going to delete this file. Get rid of the reference in index.html. Get rid of the attractor here. Comment this out. And get rid of all this. So let's run this sketch and see what happens. Great. All the mover objects are moving with their initial velocity, but there's no other forces. Now, I have a loop here that says for every mover inside of the movers array, update and show. But what do I also want to do for every mover in the movers array? Each one of those movers is an attractor to attract all the other movers. So inside of this array, while I'm looping through all the movers, I want to check every other mover. So I can write another loop inside here for I'm going to call it other of movers. Other.attract mover. Or mover.attract other? I don't know. Both would really be the same. I think mover.attract other makes a little more sense. Update the mover, show the mover, and that mover then should attract all the other movers. There's a big problem with what I've done here, but I'm just curious what happens if I run it. Whoa. Oh, cool. It kind of worked. What a nice coincidence. I'm surprised I didn't get any error. But there's an issue. It nicely just sort of like bypassed this issue, and I got no errors or nothing really crazy happened. But this particular loop is going through all of the elements of the array. Oh no, so is this one. So for every element of the array, go through every element of the array. I'm saying the same thing a lot, I know. And so it's technically possible that the mover at some point is going to attempt to attract itself, because this given mover will then appear during this loop as well. So I want to avoid that, and something that I can do is actually check to see if the two objects are equal, which which is sort of a weird thing. Am I checking to see, what am I checking exactly? So this is a little bit of an aside, but what's actually stored in a particular variable when we're talking about an object is, so if I'm talking about a specific mover object, what's stored in that variable is the memory address where all the data for that object is stored. So it's kind of like a pointer. So we can think of this variable as storing a reference, a pointer, to some place in the computer's memory where all of the data for that object is stored. So if it's stored in an array, this mover of the mover's array, the pointer is moving around and pointing to all the different objects, and maybe they're stored continuously, et cetera, et cetera. So at some point, other will actually be pointing to the same data. The same memory address will be in both of these variables. So if I check if they're equal, it's actually checking if they're both pointing to the same area of memory, which is different than if I had something like val equals 5, val 2 equals 6. And I'm trying to say, is val equal to val 2? With a primitive value like a number, it's actually checking to see if the actual thing stored in memory is equal, the data is equal. Here we're just checking to see, am I looking at the same object? That was kind of a long-winded explanation. I don't know if we need it in the video, but and maybe that didn't make any sense. So I can check right here now, as long as other is not equal to mover, then the mover can attract the other. And the result visually doesn't really look any different, but it is. But the result visually, I'm not really seeing anything majorly different here, but I've now protected the system from having that, from a given object attracting itself, which I don't want to happen. No. Amr says, I can't believe you explain pointers faster than you explain static functions. Well, that's sort of true, but I don't know if I really explained pointers there. I just kind of like glossed over it. All right. I'm going to take this variable g outside of the attract function. It's nice to have this global variable that I can use to just kind of scale the strength of the attraction force across the board. Let me just lower this down to 2. Little less frantic. One thing you might notice is the system is not very stable. As all of these objects are pulling towards each other, they're kind of, as a group, just moving off and out of the canvas. And it kind of makes sense that that would happen. But what if what I want is to experience this, but have everything really stay within the canvas? But what if what I want is to sort of experience this same animation, the same feeling that I've got with this sketch, but not have the stuff just fly off and eventually disappear? So there's a few things you might be thinking of that you could try. I mean, one is I could have a locked mover or attractor in the center that's always attracting everything, so that at a certain point, maybe it's a little bit stronger. I don't know if it needs to be stronger or not, that everything is kept within the canvas. I just realized I might have a, no, I have, that's fine. Another option could be to go back and get that edges function that I wrote. So every time one of these objects hits the edge, it's a hard edge and it reverses its velocity, bouncing back on. That would be interesting. I'd be curious to see what that looks like. But I think this is a nice opportunity for us to look at. I mean, this is quite artificial, what I'm going to introduce here. But what if I just created a force that is activated from the edges of the canvas pointing inward, and the strength of that force is mapped to how close a given mover object is to that edge? So to do that, I'm going to reintroduce the edges function. Actually, I've not done this before, so I'm like thinking about, I mean, I've done this with the steering behavior stuff. And let me just start with the left edge. So I'm going to say the difference between the x position, which is 0. So I'm actually just going to look at the x position of the object. And I'm going to say the strength of this force that I'm being introduced is a mapping, that x position, which goes anywhere from 0 to width. And of course, it could be a negative number, but the way I'm going to do this is going to account for that. And when the distance is 0, I want that force to be really strong. So let's make the magnitude just 5 arbitrarily. And when it's far away, I want it to be really weak. I think I should only activate this force if it's within a certain distance. Well, let's not worry about that right now. Let's see how it goes. And I'm going to have it 0 if it's all the way on the other side. And the force itself is a vector that just points to the right. So I'm just going to make a force that points to the right. I'm going to do force set magnitude to that strength. And then I'm going to apply the force. So this is left edge. Let's call the edges function. And let's see what happens when I run this. Well, you can see the whole system is kind of fading off to the right because there's that left edge force that's always in action. Now, let me do this again. Whoa! I don't know what just happened there. And so I'm going to reuse all the same variable names, and there's probably a more elegant way of doing this, but I'm going to say right edge, and dx equals the width minus that position. That's the difference. And that also can be, the same mapping would apply, but the vector should point the other way. Let's see what happens now. OK, let's do the top and the bottom. OK, so I've built this out with all of the edges, and there's a lot of redundant code here that could be reduced, but let's just see what happens. better, right? Not perfect, but the system is staying kind of within the bounds of the window. Now the strength of those gravitational forces are getting bigger and bigger. The accelerations are building up. I might want to put a cap on the velocity of the movers. Also something quite artificial that I'm introducing here, but I think this could help. So let me limit the velocities to like, I'm gonna give it a pretty large number, like 10. Whoa. Come back. That's weird. So what's interesting is that gravitational attraction force is so strong when they get close that they get kind of locked onto each other. And you know, maybe this limit was sort of like too strong or too harsh, or maybe I want to kind of tune it a different way and go back to this attract function to change the way that I'm doing this constraint. But I have another idea. I think it would actually be interesting to see a repulsion force. So let's actually just change this to a repulsion force. So I could rename this function to repel, which maybe would make sense, but ultimately, really what I just want to do is say force multiply -1. And let's see what happens. Oh, my wall force is terrible. I think it's not really working. Hold on. Let's take off the attraction from each other. Yeah, okay, the wall force is working. Do I have any typos in there? It's not very strong. Yeah, lowering the gravitational constant is something I could try also. One thing that I could really do to improve this is this 5 in there is really controlling the strength of that wall force as it approaches the edge. So it would make sense for me to store that like max strength in a variable. And I'm going to make that 20 just to make it much, much stronger right now. Let's run this again. Okay, now this feels tuned properly with the way that I want that edge force. There's no attraction or repulsion between them, but the walls are keeping them within the window itself. Let me lower the gravitational constant down to 1 and turn back on repulsion. The repulsion is just still much too strong. Let me lower that even more. But now I don't really see them repelling each other. Honestly, I think one of the issues here is that force keeping them on, that force keeping them within the edges is so strong it's overwhelming the attraction or repulsion force, and it's always on. Like I'm mapping that force, the x, I'm mapping the force from the edges in any direction wherever it is. So what might make more sense is for me to check to see if it's within, right? Only if it's within like 25 pixels. So maybe we can have like a buffer, which is 25. If it's within that buffer, then map the force according to that buffer, and then only apply it if it's close to the edge. Now let me do that for all the other ones. Whoops. So I have that check now in for left, right, bottom, and top. I'm going to turn off the attraction, or repulsion in this case, and run the sketch again. All right, so nothing is moving because no object was close enough to the edge to experience the force. Oh no, actually, no, they're not moving because I have an error. Strength is not defined, mover line 46. Oh, look at this. So actually, this is kind of better because I had these, now these variables are local variables to the if statements. Run this again. So they're staying within the canvas, and that force is only activated if it's within 25 pixels. Let's make that 50, and let's make that force much stronger. Oh, you can see now, this is much more like a bouncing ball sketch in a way, because that force only activates when they get close to the edge, and it's very, very, very strong. Now I think that I could add the repulsion back in and increase its strength. The repulsion is so strong, they're all trying to stay very far away from the corners. Boy, this is not what I wanted at all. Let's weaken the repulsion. Let's go back and make this attraction. Ooh. It's a mover train. Look at what an interesting little weird thing that I created. What if the distance is within a certain threshold, they repel each other, otherwise they attract each other? Ooh, that's an interesting thing I could try. I want to go back to just using the raw distance, not the distance squared, which I think is easier for me to kind of think about. So we'll make this between 10 and 50, and then we'll actually say here distance times distance. And then I'm going to say if distance is less than, what's being constrained, is less than 20, make it a repulsion force. Let's see what happens now. So they're all attracted to each other, but then when they get close, they kind of repel. Yeah, interesting. So you can see I could play with this forever and ever, and I assume while you're watching this, you're like, oh, whatever you're doing is so silly. I have a much more creative and interesting way to make this a dynamic, compelling, beautiful, artistic visualization. Please go ahead and do that and share it with me. I would love to see it. There is something that I should point out here, which is that I am not, the order of the movers is kind of playing a role here in the sense that I am updating their location and then applying a bunch of forces and then updating the next one's location and then applying all the forces. If I wanted to be much more exact about this, I would want all of the movers to accumulate all of their forces based on their current position and then all update together. So it could actually make sense for me to do that. To have two separate loops. One where I update and draw them all, then I apply a whole bunch of forces based on those fixed positions, and then update them all together all at once. We'll see if this actually has any different quality to it. Another aspect to this is I'm not considering anything. I'm not considering another aspect of this is another aspect of this, what was I going to say? Oh, another aspect of this is I'm not treating these as rigid bodies. Notice how they can easily move over each other. I'm not worrying about actual collisions here. That would be a whole other complex thing for me to work through and implement. And in many cases when I'm doing collisions, I end up using a physics library, and I have some videos that will appear in this playlist about that, using a library called matter.js. But ultimately, I think this really wraps this up. This wraps up chapter 2 of the basic idea of looking at the universal laws of motion, Newton's laws, how those laws of motion can be applied in code, not in an accurate, perfect way, but in a way that reflects the sort of core ideas of them, but is easy to implement and runs kind of fast. And then what kinds of things do I need to adjust or tweak or sort of fudge to kind of to create the simulation or visualization that goes with whatever story or that I'm trying to tell with my sketch. And I don't really have a story that I'm trying to tell other than I'm trying to teach how this stuff works and how you could apply it. But I hope that you have an idea or a story or a project you're working on where this applies. So if you do, share it with me. Find a link to the codingtrain.com page where you can share your work in this video's description. You could also join the Coding Train Discord and share your work that way. And I look forward to seeing you in chapter 3, where I will get into trigonometry. I hope you're excited. I'm really excited. And I shouldn't have played that sound effect. I should play like a beautiful sound effect, like birds singing, because trigonometry, it's our friend. We'll be there together enjoying trigonometry together in the next video. This one really has to end now. I'm just talking way too much. Goodbye, and see you soon on the Coding Train. Ah! Oh, that was like the worst ending ever. Yes, Luke is writing, is this an implementation of G equals M1 times M blah, 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 blah. So the divide by 0 thing is something I really should protect against. I should have a check here that says if distance is, as long as distance is greater than 0, go forward and multiply. But I'm choosing to not bother with that extra error check, mostly because it's just not going to happen with floating point math, that these pixel values are going to be exactly the same. And then I'm also constraining it. Oh, actually, it's never going to happen because I'm constraining it to between these two values. So I'm actually protecting against that here with this extra constraint that I'm adding. All right, actually, I thought I was going to have all this extra time, which I clearly do not, because I only have about 10 minutes. But 10 minutes is actually quite a bit of extra time. And maybe people have questions, or there's some other things I wanted to mention. Maybe I should re-record an aspect of this. I feel like I was really fumbling towards the end there, but it is what it is. Questions? Oh, there was a super chat from Vito List. Thank you. I'll press my choo-choo button. Let's see. There's probably people who joined now who didn't, who weren't here at the beginning of the stream. So let's look at the Pi Day. Let's see if anybody added any Pi Day issues. No. There's no new ideas for Pi Day. Where are you, my people? Let's see what there is previously. Oops, no. I want to look at Pi Day ideas. Generating pi from random numbers. I think I did basically that already. Oh, coprime. Oh yeah, the stand-up math video. Okay, that's interesting. So I haven't done this one, the coprime thing. I did the dart throwing one idea. I like this. That's certainly a possible. Pi-lish generator. What if I trained a machine learning model with the digits of pi and then asked it to generate pi? That seems kind of silly. Yeah, good opportunity to talk about coprimes. Literary nerds invented a dialect known as Pilish, in which the numbers of letters in successive words match the digits of pi. For example, Mike Keith wrote the book Not Awake entirely in Pilish. Now I fall, a tired suburban in liquid under the trees. Okay, this is kind of awesome. Okay. Pilish. This is, this I like. I like this idea. Thumbs up. I'm going to assign myself. So that is not at all in the wheelhouse of things I was thinking about, but could absolutely work. Pi Day Challenge, calculate million digits of pi. I don't know how to do that. I wrote some code based on somebody else's code, based on an algorithm that was doing that. Pi Day Challenge. 3D Monte Carlo approximation of pi by dropping raindrops into or outside a puddle. That's very similar to what I did already. I didn't do it in 3D with a lot of visual flair to it, but that's an interesting idea. Oh wait, I'm already at that one. Visualize an infinite series. I think I need something more specific. I like this suggestion. Pi Day Challenge. Audio visualizer. Okay. This I did. Oh, a Gaussian rather than a circle. This is interesting. It's a little bit similar to what I did previously. I guess I'm a little less interested in pi approximation since I've done that before, although this is really an interesting one to see. Thank you. This is a great example, del squared. This is awesome. List of Pi Day challenges. Oh. Pi art. Countdown to the next Pi Day. Oh, I like that. Use pi in any object you make. Use the line function to manually draw the numbers of pi. Some nice ideas. This I did. Oh, I didn't use matter.js. This is what I did last year. Pi music, pi rock concert. Make a sheet of pi music. This I really do like, the idea. But here's the thing. When I've done things where I visualize the digits of pi, there's so much mystery and meaning in those digits, but ultimately the distribution of them is really just like a bit of a pseudo-random number generator. And I know there's more to it than that, but I don't know, would I get anything melodic or meaningful by assigning the digits of pi to note values? So that I think is a really terrific idea that I would like to do. Maybe some of you who are musicians or sound artists might have some specific ideas of how I might implement this. But I'm going to keep this on my list. Ooh, ASCII art. I know that Violet has done work with ASCII art. Yeah. This one especially. Whoa. So yeah, ASCII art with the digits of pi, that's an interesting idea. I feel like I need a little bit more focus to this. You could use pi's decimal development consecutive digit to represent the pi. Yeah, I think I need something that's sort of connecting to the sort of like mathematical aspects of pi themselves. I mean, making just like a pi is fun. Oh, right, pi approximation day, which is 7/22, right? July 22nd, which is 22. So now I'll come back. Somebody remind me to do this in July. STEM coding project, P5 just. I've done so many pi approximating things. This is similar to what I did already. Spiral. Okay, you had me at spiral. Ooh. Oh, that's cool. This is kind of fun. Is there something about this that's tied to the math of pi? Probably in the sense that I'm doing polar to Cartesian coordinates. Old school pi demonstrations. I like old school. Oh. This is super interesting. This is actually highly relevant to Chapter 3 of Nature of Code. So I'm going to consider this one, rolling wheel full of paint. I like this idea a lot. Pi is made of pi. Yeah, make a visual image of the character pi made of lots of little pi for him to make the larger character. Yeah, so this I can sort of imagine this. That's kind of in the ASCII art territory. Draw a circle with pi numbers. This is a suggestion from Simon. Whoa, oh boy. Oh boy. Oh boy. Boy. So these are definitely I could consider. I think I was looking to do something more visual and less pi approximation-y. Calculate the. I don't think this is possible. I mean, I could train GPT-2 on or like a recurrent neural network on the digits of pi. Could it learn like what? I mean, that's sort of an interesting idea. I mean, I don't think this is going to work, but like I'm going to like keep this in mind as something that I could do. Where am I? I also need to do a song. So I got my ukulele, song ideas. Oh, it's noon o'clock, I gotta go. Search for words in pi. This I like. Oh, this I like. This I really like, okay. I'm gonna add that. So there's a lot of nice ideas here. Oh boy, there's so many. Pi City Skyline. Pi in the sky. Oh, interesting. So these are like the digits of pi in a skyline. Wow, so much nice idea. I see there's like looks like there's a 3 blue, 1 brown video being posted. Okay, I think I gotta go. There's actually quite a bit of all, okay, yeah. Yeah, these were the original suggestions. Yeah, so I've done stuff like this, which I really like. But I don't want to just copy somebody else's beautiful art. So I would need kind of a new creative idea, but that I have done. Oh, here we go. Oh, that's the proof. Okay, so I'm going to look through these some more. Thank you for those suggestions. Someone added a new suggestion. I don't know why I'm not seeing it. Oh, because it's not, doesn't have the label yet. So let's label this Pi Day. Bake a pie. I mean, I kind of really want to do that. Pi Day comes at a very difficult time because it's right in sort of like the prime, like March 14th is like spring break for NYU is the week after. So if Pi Day were like a week later, I'd have a lot more time to like maybe do something kind of special or have like a whole day stream. And it's really busy right now for me. So I might have to just do something quick, but I might record it in the Cabana, although those take a look longer and harder to produce. So anyway, thank you for all these ideas. I'm going to get going. Thank you again to Dashlane as the sponsor of today's live stream. Dashlane.com/codingtrain will get you a free 30-day trial and 10% off if you purchase the premium subscription. Dashlane is a password manager and Cooking in the Cabana. And I'll be back next Thursday. So I'm pretty locked into this Thursday thing. I can tell you though that, let me just look at the calendar for a second. What month is it? Today's what? Is today March 5th? I don't have my watch on anymore. Yeah. Okay. I was going to open up Google Calendar, but I'll just open this. So let me pause for a sec. March 12th, we're on. Oh, Pi Day is Saturday the 14th, which would be like a good time to do something, but I'm going to be traveling, assuming traveling is still a thing. It's close travel, but I won't be available to live stream. So March 12th will be next week. I guess I could maybe try. I could do actually some of these challenges, and then Mathieu and I could edit them together quickly. When I say we, I really mean Mathieu will do it, and I'll be like, thank you. But to come out on the 14th. And then March 19th, I will also be doing a live stream. The 26th, I am not available. So I believe the live streams for this month will be 5th, 12th, and 19th. And then if I can get my act together, and at some point the channel hits 1 million subscribers, maybe I'll try to come do an extra sort of bonus live stream whenever that happens as a little celebration. So thank you, everybody. Any more questions anyone wants to ask before I go? Shivam says, you taught me P5JS and ML5JS, and I got an A grade for the project. Thanks a lot. Congratulations! I'm glad you got an A, and every grade is a great grade to get. If you learned something and got a B, I congratulate you as well. It's always nice to hear when people are applying stuff from this channel to school, or to work, or their own creative, just hobbies. I love hearing that. Thank you. JNP asked, what classes do you teach on campus? So I teach a variety of different classes at NYU, part of the IMA program and the ITP program. Those are at Tisch School of the Arts. I also teach some online classes for NYU using some of these videos, learning to code. Currently I'm actually teaching the Nature of Code course, which is why I'm focusing on making the videos during these live streams that get edited into a playlist. And I've just been really behind. But I the playlist is there, and I'm going to make it unlisted, available for people to see pretty soon. So if you, the videos will slowly be made public on the channel. So if you're subscribed, you'll get notifications. If you click the bell, blah, blah, blah. But if you join the Discord, that's a place where I'll make sure to share when there's some extra unlisted videos that you might want to check out as well. Thank you, Jason writes, I love your book. Which book? I wrote two! I'm really trying to get a new edition of Nature of Code out. I'm actually working on it. I'm probably working on it maybe at a maximum 2 hours per week, and it really needs 8 to 10 hours per week for me to make more progress. But I'm editing, there'll be a new version out soon enough. Usman writes, I am new to programming. All right, there were only 10 seconds left there, so I had to pause. So one thing, and thank you especially to Violet, who has done a lot of this work. Oh, you can't see this. But the Coding Train website, you should be able to find things on YouTube itself. But the website mirrors all the YouTube content and has extra things. But one thing that it does is it kind of highlights specific playlists. So under beginners up at the top, P5JS, this will take you to the the set of beginner videos. So if I were to go click on watch on YouTube, it's going to, now why does it not, it's going to show with this first video. And one thing that I would also note is that a lot of these things are in these learning playlists. So if I click here, you'll then see this interface which has all the videos and different sections of all this content. So, if you're new to programming, there are many other places and videos and books and tutorials and communities where you could learn to code. This is just one of many, but this would be my playlist that's designed for people who have never coded before. All right, thank you everyone. I am going to say goodbye. I will play you out with a bunch of the Coding Train remixes. There's some new ones that are coming in, and it crossed my peripheral vision that I saw someone post. There's like a new remix with maybe position. Let me see if I can find it. All right, hold on. Somebody help me find this. There was a new Coding Train remix, which I am now going to attempt to play you out with. Sound. We open up the Discord. Somebody posted it in the Discord. Where? A remix, maybe, if I search for. Position. Oh yeah. Oh, I posted it. Let's try it. Let's try this one. Oh, the track was not found. Maybe it has been removed. Okay, wait. Maybe somebody else posted one. My position remix of today's live stream. It's gone. Does anybody know what I'm talking about? I really have to go. But I really want to find this remix. Let me just search position, I guess. Oh boy, there's a lot of people asking questions about code examples with the word position in it. All right, I guess I can't find it. It was Titan. A user named Titan had created a remix with position. Let me go to SoundCloud. Coding.
So this is random, this is noise, Perlin noise that is. In the core random algorithm, the actual random algorithm itself, those numbers aren't related at all. You pick, like, I'm picking random numbers between 0 and 10. 9, 2, 7, 6, 1, 9,
all right.
4, 8, 9, 2,
this,
1,
by the way,
3.
is the SoundCloud playlist.
Perlin noise, I might pick numbers like
this. A lot
of
remixes
2,
that people
3,
have made,
4, 3,
and I will play a bunch
4,
of them
5, 6,
as
5,
I
4, 5,
go off
6,
about
7,
thank you,
6,
everybody.
7,
And
5,
I will
6,
say,
7,
I know
8,
someone said
9,
quaternions,
8,
so I really got to go now.
Perlin noise performance art. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I think 9 last. 2, 3, 4, 3, 4, 5, 6, 5, 4. Look, this is like Perlin noise performance art. 7, 5, 9, 2, 7, 6, 1, 9, 4, 8. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Perlin noise, that is. Perlin noise. So this is Perlin noise, that is. Perlin noise. This is Perlin noise, that is. Perlin noise. So this is Perlin noise, that is. Perlin noise. Perlin noise, that is. Perlin noise. So this is Perlin noise, that is. Perlin noise. This is Perlin noise, that is. Perlin noise. So this is Perlin noise, that is. Perlin noise. Perlin noise, that is. Perlin noise. So this is Perlin noise, that is. Perlin noise. This is Perlin noise, that is. Perlin noise. So this is Perlin noise, that is. Perlin noise. Perlin noise, that is. Perlin noise. This is Perlin noise, that is. Perlin noise. This is Perlin noise, that is. Perlin noise. So this is Perlin noise, that is. Perlin noise. Apparently. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Well, this is like Perlin noise performance art. As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot song. This dot, this dot. This dot, never forget this dot. This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody compose that song for me. This dot neighbor count equals 0. Flood fill time. It's flood fill time. It's flood fill time. It's flood fill time. I'm not going to look it up how it works. I'm just going to make up my own way of doing this. This dot, this dot, this dot. Flood fill from Wikipedia, also called fill, is an algorithm that determines the area connected to a given node. No, you reveal yourself. No, you reveal yourself. You reveal yourself. You reveal yourself. Everybody reveal themselves. Then we've got a problem. So now what I need to do is I need to go and look at all of the different things. Different things. It's flood fill time. 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 Different things. Different things. I could do better, but anyway, there was an error. The song didn't load. And then there's a callback that's like, it's loading, it's loading, it's the loading song. It's loading, it's loading, it's the loading song. So let's see if this works now. It's loading, it's loading, it's the loading song. 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 It's loading, 1, 2, 3, 4, 5, 6, 7, 8, 9. Loading, it's the loading song. It's loading, it's loading, it's the loading song. It's loading, it's loading, it's the loading song. It's loading, 1, 2, 3, 4, 5, 6, 7, 8. 9. Loading, it's the loading song. It's loading, it's loading, it's the loading song. It's loading, it's loading, it's the loading song. So what I was really expecting to happen is for those not to come in order. They did come in order, which is kind of lucky, but there's no way to guarantee that they're going to happen in order. So that's how to program a loading song. It's loading, it's loading, it's the loading song. It's loading, it's loading, it's the loading song. It's loading, it's loading, it's the loading song. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Loading, it's the loading song. It's loading, it's loading, it's the loading song. It's loading. Oh, I need a soundboard really badly. The loading song. Of course, I could do sound synthesis myself. And then listen. Triangle to twirl. Oscillator. One full cycle that just repeats over and over again. All aboard!
say once again, here we go, sing it with me. It's the polar to Cartesian coordinate song. It's the polar to Cartesian coordinate song. Auto-tune and the internet will fix that for me. Sing it with me. It's the polar to Cartesian coordinate song. It's the polar to Cartesian coordinate song. It's the polar to Cartesian coordinate song. It's the polar to Cartesian coordinate song.
Unicorns and rainbows and cupcakes. What else is there? Yes, kittens. Thank you very much. Kittens and rainbows and cupcakes. Notice that. Look what I get. I'm really losing my mind. Okay, let's do it. Kittens and kittens and kittens and kittens. 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 Kittens and kittens and kittens. Kittens and 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 kittens and kittens and kittens. I feel just sort of like a nice feeling of relaxation. Everything's going to be okay today. Dream is not broken. It has not frozen. This is a wonderful thing. Okay, we're going to do it. I'm really getting to something. I need my sound effect. Unicorns and rainbows and cupcakes. What else is there? Unicorns and rainbows and cupcakes. That was invalid syntax. I forgot. There was one other thing here that I think is important that I will use continuously over and over again in all sorts of text generation analysis things. That I will use continuously over and over again. First thing I need to do is, yes, kittens. Kittens, kittens. I'm really losing my mind. Okay, we're gonna do it. Kittens and kittens and kittens and kittens. 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 Kittens and kittens and kittens and Das Vidania.